What we're going to be talking about in this video is how can we use the Impulse-Momentum Theorem to solve problems. And if you remember, the Impulse-Momentum Theorem says that essentially anytime you apply a force to an object over a period of time, you will change that object's momentum. And we can write this out as anytime you apply a force to an object over a period of time, we will change that object's momentum. Okay? Remember, this is a changing momentum, and F delta t we've defined as an impulse. So in order to change the momentum of an object, we have to apply an impulse. Now, how can we take this relationship and apply it to a scenario in order to solve a problem? Well, here's our first problem, okay, and the one that we'll be doing and using as our example. A soccer ball is kicked from rest to a speed of 10 meters per second. If the ball has a mass of 450 grams and the foot is in contact with the ball for 0.5 seconds, what is the average force on the ball? Well, we know the ball is going to start at rest and move to 10 meters per second. It has a mass of 450 grams and a contact time of 0.5 seconds. And we're trying to calculate the average force. In this case, we would use the Impulse-Momentum Theorem to attempt to solve this, because we know that some force is applied over some period of time to some massed object to change its velocity. So I know that there's going to be some impulse to change some momentum. So I can say that F delta t is m delta v. Okay. Well, I don't know my contact force. I know that the time is 0.5 seconds. I know that the mass of the ball is 450 grams, but we do have to convert that to kilograms. So we divide that by 1,000, and it becomes 0.450 kilograms. I know that my change in velocity is my final velocity minus my initial velocity. My final velocity is 10 meters per second, and my initial velocity is at rest, so it's 0 meters per second. So my change is 10 meters per second. And I'm asked to determine a force. Well, I know that I can rearrange this equation, divide both sides by delta t, and I'd get F equals m delta v over delta t. So then my force, let me just separate that out, equals 0.450 kilograms times change in velocity of 10 meters per second over a contact time of 0.5 seconds. And when we do this, we get a force that's, let's see, 9, and force is measured in newtons. Okay. Now remember, when we're going through this essentially started with our impulse-momentum theorem. F delta t is m delta v, and we were able to decide where everything was supposed to be placed. We started at rest. We decided this object then was being kicked in the positive direction at 10. Okay. We knew the mass of the ball was 0.45, and we knew that the contact time was 0.5. So we're able to decide where all this stuff gets placed and how to decide this situation. Okay, and I seem to have gone outside my area there, but there is the finishing calculation.